All right, here's the Unit 2 practice test video. So the first question, I'm not going to read the whole thing, but it says it's supposed to weigh 6.25 grams. There's variability, so they don't weigh exactly 6.25 grams. The distribution of weights is approximately normal with a mean of 6.25 and a standard deviation of 0.2. We want to know what percentage of Oreos will weigh less than 5.9 grams. Okay, so this is just a standard z-score problem. We're going to sketch a picture here, right? If our distribution, we don't need to sketch all of the standard deviations, but the mean is 6.25. And we want to know what percentage will weigh less than 5.9. So if 6.25 is here, 5.9 is going to be somewhere to the left. So this is 5.9. And since we're looking for less than, that means to the left. So we're looking for this area right here. All right, so now we're going to go ahead and calculate our z-score. So we're going to do the data value, which is 5.9, minus our mean, 6.25, divided by my standard deviation of 0.2. So 5.9 minus 6.25 divided by 0.2, we get negative 1.75. And since we're looking for the area to the left, really what we're trying to find is a probability that z is less than negative 1.75. So now we're going to go to GeoGebra, to GeoGebra, and we're looking for less than. So we pick this one, and our z-score is negative 1.75. So that's going to be 0.0401. However, since it asked for a percentage, we're going to multiply that by 100 to get the percent. That's going to be 4.01%. So for the sake of time in this video, I'm not going to write every answer in context, but our answer would be the percentage of Oreos that weigh less than 5.9 grams is 4.01%. All right, so the next question says, the time of each of Beyonce's songs approximately normal with a mean of 255 seconds and a standard deviation of 30 seconds. What percentage of her songs will be under 4 minutes? So first thing we need to make sure, since this is given in seconds and this is given in minutes, we need to make sure we know what this is in seconds. So 4 minutes in seconds, we just multiply by 60. So that's 240 seconds. So again, I'm going to sketch a distribution here. We have our mean is 255. Standard deviation is 30, but I'm just going to place this on my sketch. 240 seconds is somewhere down here. And we want to know what percentage of our songs will be under. So under again means to the left. So there's 240 seconds, 4 minutes. We're looking for this area right here. So like the previous problem, we're going to find z. So it's going to be 240 minus 255 divided by 30. So 240 minus 255 divided by 30. We get negative 0.5. Right, and then since we're looking for the area to the left, again, we're looking for less than. So we're going to go to GeoGebra. We already have it as less than, but I'm going to change my z-score to negative 0.5. We get 0.3085. And again, since we're looking for a percentage, we're going to multiply that by 100. So that's going to be 30.85%. So again, in context, we would say 30.85% of Beyonce songs are under 4 minutes. All right, next question. It says, what is the probability that the z-score is more than negative 2.45? So using our notation here, it's more than negative 2.45. So this is a simple problem where we just have to go into GeoGebra. We switch to more than. Negative 2.45. That's going to be 0.9929. What percentage of values fall between a z-score of negative 0.98 and 2.57? So we want between, so negative 0.98 is less than z is less than 2.57. If you want to sketch a picture for these ones, you can, but it's not necessary. So between is going to be this one right here. So negative 0.98 and 2.57 gives me 0.8314. All right, the next question says that we have Oreos labeled being 14.3 ounces. However, the weight has a normal distribution with a mean of 15 ounces and a standard deviation of 0.25 ounces. We want to know what proportion of packages are underweight, meaning less than 14.3 ounces. So again, I'm going to start with my picture. I'm going to put my mean in the middle, 15.0. And then less than 14.3 is going to be somewhere down here. And again, for this problem, we are looking for less than. So now we're going to go ahead and find our z-score. So it's going to be 14.3 minus 15 divided by my standard deviation of 0.25. .3, 15, 0.25. So I get a z-score of negative 2.8. And the way I shaded it, z is less than negative 2.8. So now we're going to go to GeoGebra. We're going to select less than, and this is going to be negative 2.8. And that is going to be 0.0026. In this case, since it just asked for a proportion, we can actually leave it as the decimal, 0.0026. So answering in context, I would say the proportion of packages of Oreos that are underweight is 0.0026. Question number 6 says the time taken for new Beyonce dancers to learn a new routine has a normal distribution with a mean of 122 minutes and a standard deviation of 17 minutes. We want to know the proportion of new dancers that it takes more than 2.5 hours to learn a new routine. So again, we need to make sure we convert the hours to minutes. So we're going to multiply that by 60. So that's going to be 120, that's 150 minutes. Since 2 hours is 120 and 2.5 would be adding half an hour. So we're going to sketch a distribution. The mean is in the middle, 122. Standard deviation is 17, and we want to know 150 minutes. So if 122 is in the middle, we know 150 is going to be somewhere to the right. And since we're looking for more than, that's to the right. So this is the area that we're looking for. So now we're going to find a z-score. So it's going to be 150 minus 122 divided by 17. That gives me 1.65. So we're trying to find the probability that z is greater than 1.65 because we're looking for more than. So I'm going to switch to more than, and that's going to be 1.65. That's 0.0495. And again, since they asked for a proportion, we can leave that as a decimal. So in context, we would answer the proportion of new dancers that takes more than 2.5 hours to learn a new routine is 0.0495. All right, so now let's take a look at question number 7. So question number 7 says the Billboard chart ratings are normally distributed with a mean of 75 and a standard deviation of 14. And it tells us that the bottom 10% are banned from music forever. We want to know what's the lowest score that they must receive to be allowed to continue making music. Okay, so this is a working backwards problem, and I know that because we're starting with a percent. We're still going to draw our picture, though, so the bottom 10% is down here. Okay, we know that our mean is 75. So we're looking for this score here that would separate the bottom 10%. So in this case, we're going to have to use our z-score table backwards, or the calculator backwards rather. Okay, and we want the area to the left here, and we know we want that area to be 10%. So we type in, well, I typed in already, 0.10 here, and that's going to give me my z-score that separates the bottom 10%. So in that case, it's going to be negative 1.28. And then we're going to work backwards. So negative 1.28 equals x minus the mean, which is 75, divided by the standard deviation, which is 14. All right, so to solve, we're going to multiply both sides by 14. So 14 times negative 1.28 gives me negative 1.792. Actually, negative 17.92. So we have negative 17.92 equals x minus 75. And then we're going to add 75 to both sides. So that's 57.08. So to answer in context, we would say the lowest score that an artist must receive to be allowed to continue making music is 57.08. All right, question number 8 says the time it takes for artists to deliver their acceptance speech at the VMAs is approximately normal with a mean of 85 and standard deviation of 8 seconds. How much time should be given to complete the speech so that 85% of artists will complete their speech in the given time, meaning 85% complete it in that time or in less time. All right, so again, this is a working backwards problem because I know that we're given a percent. So in this case, it's going to be a less than problem because it's 85% will complete their speech in the given time. So we want them to do that time or less. And if we want that piece, that's going to be the area to the left. We want that piece to be 85%. So it's going to look something like this, right? And we want this area to be 85%. So in that case, we need to figure out what is this value right here. We know that my mean is 85. So we're going to use our table here. We know we're looking to the area to the left, and we want that area to be 85%, 0.85. So our z-score is we'll say 1.04. And then we're going to work backwards. So x minus the mean divided by the standard deviation, which is 8. So when working backwards, we're going to multiply both sides by 8. So 1.04 times 8 gives me 9.04. So we have 9.04 equals x minus 85. Then we're going to add 85. That gives me 94.04. So to answer in context, the amount of time that should be given to complete the speech so that 85% of the artists will complete their speech in the time given is 94.04. Right. Number 9, it says the time it takes Kanye West to write a song has a normal distribution with a mean of 122 minutes, standard deviation of 6 minutes, and it says on 92% of all occasions, the songwriting process will take less than. So less than indicates that we're looking for the area to the left, and we want that area to be 92%. So something along these lines. We know that our mean is 122 minutes, and we want to figure out what is this value right here. So again, we're going to use our table backwards, or our calculator backwards. We're going to type in the percent that we want, which is 92%. And that's going to give us our z-score. So it's going to be 1.4, we'll say 1.41 equals x minus the mean divided by the standard deviation. Just like with all the previous problems, we're going to multiply by 6, standard deviation. So we have 1.41 times 6 gives me 8.46 is equal to x minus 122, and then we're going to add 122. So yeah, that gives me 130.46. So to answer in context, we would say on 92% of all occasions, the songwriting process takes less than 130.46 minutes. And number 10 says a soda machine can be set up to pour an average of any amount of soda, and that the ounces of soda poured is normally distributed with a standard deviation of 0.6 ounces. We want to know what value should be set, should the average be set at so the 5.5 ounce cup will overflow only 1% of the time. So in this particular problem, we don't know what the average is. We don't know what the mean is. However, we do know what our data value is, right? So it's going to be set up as Z equals our data value 5.5 minus the mean divided by the standard deviation, which is 0.6. Okay, it is still a working backwards problem because we are given that percent. And if we think about it overflowing, we only want it to overflow 1% of the time. So since it's overflow, that means it's more than, and we want that area to be 1%. So this area is 1%. So let's go back to our probability calculator. We want the area to be 1%, which is 0.01, but we want that area on the right-hand side. So that means that oops, 0.01. Our z-score is going to be 2.33. So it's going to be 2.33 equals this. And just like before, the first thing we're going to do is we're going to multiply by the standard deviation. So 2.33 times 0.6 gives me 1.398 is equal to 5.5 minus the mean. And then we have a couple options. We could add the mean. I'm going to do that so I can get my variable positive. So we have the mean plus 1.398 is equal to 5.5. And then we're going to subtract 1.398 to solve for the mean. So we have 5.5 minus 1.398. So that means our mean is equal to 4.102 ounces. So in order, the value should be set at 4.102 ounces so that a 5.5 ounce cup will overflow only 1% of the time. This would make sense logically because if you don't want a cup to overflow, you want to set it so the machine is lower than what the cup is. That means it's only going to overflow every once in a while when it malfunctions. The distribution of Oreo weights can be approximated by a normal distribution with a mean of 6.25 grams and a standard deviation of 0.2 grams. So part A says sketch a distribution of Oreo weights. We're going to use real world values to label 1, points 1, 2, and 3 standard deviations from the mean. Okay, so we know that our mean goes in the middle, so this is going to be 6.25. To get one standard deviation above, we're going to add 0.2. So I'm just going to do all my calculations here, and then I'll write it down. So 6.25 plus 0.2, that would be one standard deviation above. And then we're going to add 0.2 to that again to get two standard deviations above. And then we're going to add 0.2 to that to get 3 standard deviations above. So one standard deviation was 6.45. 2 standard deviations above is 6.65. And then 3 standard deviations above is 6.85. I guess I don't really need a calculator for this. Remember, these are all grams, so we should always include our units. one standard deviation below. So we're going to we're going to subtract 0.2. So that's going to be 6.05. And then we're going to subtract again. So that's going to be 5.85. And subtract 0.2 again. So that's going to be 5.65 grams. All right. So now it says find the proportion of Oreos weighing less than 6 grams. So in that case, we're going to place it on our distribution. So less than 6 is going to be around here. And less than is the area to the left. So we're looking for that area there. So now I'm going to find out what my z-score. This is not a working backwards problem because we're not giving a percent. We're trying to find a percent or proportion. Our data value is 6 minus the mean, which is 6.25, divided by the standard deviation. So 6 minus 6.25 divided by 0.2 gives me a z-score of negative 1.25. Since we're looking for the area to the left, we want to find the probability that z is less than negative 1.25. So now I'm going to go to my z-score calculator. I'm going to select less than, and I'm going to type in my z-score, negative 1.25. That's going to be 0.1056. So I would say the proportion of Oreos weighing less than 6 grams is 0.1056. All right. Part C says proportion of Oreos weighing between 6.6 and 6.7 grams. So this is between. So 6.6 is maybe around here, and 6.7 is around here. We're trying to find this proportion. So we're going to have to find two z-scores. So for the first z-score, our data value is 6.6. And our second data value is 6.7. So 6.6 minus 6.25 divided by 0.2. So the first z-score is 1.75, and then 6.7 minus 6.25 divided by 0.2. 2.25. So I have my two z-scores, 1.75 and 2.25. And now we are going to go to our probability, and we're looking for between. So we're going to select this one, and we're going to type in our two z-scores, 1.75, 2.25. This matches what our picture looks like, and that proportion is going to be 0.0278. So we want to find the proportion or the probability that z is between 1.75 which is 0.0278. So to answer in context, the proportion of Oreos that weigh between 6.6 and 6.7 grams is 0.0278. All right, question number 12 says a distribution of annual profit at a chain of stores was approximately normal with mean 66,000 and standard deviation of 21,000. Stores with the profits in the top 5% had a reward party for employees to celebrate. We want to know what is the minimum annual profit for a store that had a reward party. Okay, so we have our mean here at 66,000. And this is a working backwards problem because they give us a percent and we're looking for a data value. So it says the top 5%. So top is to the right and we want that area to be 5%. So maybe something along these lines. So this is the area and that is 5%. So we want to know what is that data value. So first off, we need to figure out what is our z-score that separates the top 5%. So we're going to go to our calculator and we're going to use it backwards. We want the area to the right and we want that area to be 5%. So 0.05. So that's going to be 1.64. We're looking for that data value. That's x minus the mean, which is 66,000, divided by the standard deviation, which is 21,000. All right, solving for x, we're going to multiply both sides by 21,000. 1.64 times 21,000. That's 34,440 equals x minus 66,000. And now we're going to add 66,000. So 34,000 plus 66,123. That gives me 100,440. So the minimum annual profit a store that had to have a reward party is 100,440. All right. Lastly, it says listed below are the unemployment rates for 50 states. Explain in words how we can use our calculator to determine whether or not the unemployment rates are normal. So in terms of a calculator, we're talking GeoGebra. So in words, I'm not going to write this all out. We would get our data into GeoGebra. We would do one variable stats and create a normal quantile plot. So we do need to make sure we use the correct vocabulary, that it is a normal quantile plot. And we need to make sure that that is linear. So we're going to make a normal quantile plot. And we want that to be linear. So we're going to click here for the data. And we're going to go ahead and put that into GeoGebra. So for GeoGebra, we're looking for a spreadsheet. I'm going to copy my data values here. I'm going to paste it. One variable analysis, and then we're going to change our graph to a normal quantile plot. So since our graph is roughly linear, we would determine that this data is normally distributed. So again, we're looking for the normal quantile plot, and we're looking that the shape is roughly linear.